All right, this time, let's try to differentiate a to the x using the chain rule. The first rule that you have to know is that if you have any exponent with a log with that base, exponents and exponentiation and logs cancel. You know this property, right? So because ln means log with base e, if you have e to the ln of any number, or just a, then e to the log e of a, these two cancel and you get a. Right? So you get the following identity. E and e to the ln of a is the same because e and ln cancels each other. Okay? Now, because we really want to differentiate a to the x, and we have no idea how to differentiate a to the x, we want to use the fact that e to the x prime is e to the x. So our temporary goal is to make a to the x look like e to some power. Okay, how do we do that? Well, because a is same as e to the ln of a, I can replace this a as e to the ln of a, this thing inside. Right? So since this is a, this still should read to you like a to the x, right? Okay. And then there's an exponential rule that says if you have two exponents, what are you supposed to do? You have to multiply, right? The rule is like e to the 2 to the m to the nth power. If you have exponents like this, what's the rule? It should be multiplied, m times n, right? So these two are multiplied. And therefore, we get this identity that a to the x is same as e to the ln of a times x. Where ln of a, although it looks very frightening, it's just a number, it's just a constant. So if you think you're not ready for this question, try to differentiate e to 3x, which was the previous example, right? Try to just follow how you did the derivative of e to 3x, and just think of that 3 like this ln of a, right? ln of a is like that 3 in front of x, right? So you can differentiate this using the chain rule, following the exact steps that you did for example 3. Okay? So try that. I mean, again, if you have trouble understanding it, a good way to do it is to have something like this, cover it, right? So ln of a times x, the entire thing is considered as the nested function inside. If you differentiate e to the x, what is e to the x? E to the x prime is e to the x, where that x is really what I've covered. So you're really treating this entire thing as x, right? And then the chain rule says the inside function has to be pulled out and differentiated. So ln of a times x has to be differentiated. Okay? This is just a constant multiple times x, so you really need to just differentiate x, right? When there's a constant multiple, you ignore that, just leave it there, but just differentiate the function that comes afterwards, right? So ln of a times x prime, that's what you need. And x prime is 1. You get e to the ln of a times x times 1. What is this? Oh, no, ln of a times 1, right? Now, what is this?
X.
This is this, which is a to the x, isn't it? Right? So we have a to the x ln of a. Okay. Now, not only is this a good example problem for how to use the chain rule, you can actually put this as a new list of derivatives that we know, okay? So, in general, when you have a to the x, when you differentiate this, you get a to the x times ln of a. Okay, so we can, we now have a new item on the list of derivatives. Okay.